Welcome guys, so keep solving our physics subject GRE. Okay, so 41 is the common question. Basically, if you have the magnetic monocouple, then your divergence of B need to be changed. You can add a term like rho B. So the second must change. And once the second change, then the third must be changed. The reason is that since if you take the divergence of this, then you will get this. Okay, so originally this is 0 by mathematics. So this is the math identity. Okay, but you can prove by yourself, but it's very easy that common sense. Okay, but so originally if you do not have rho B, then the right hand side is 0. But now the right hand side is non-zero. So if 2 is correct, then 3 must be changed. Otherwise, the mathematically has a conflict. Okay, so the answer is 2 and 3. Answer is E. Answer is E. Okay, 42 say that a 3-wire loop. Okay, so basically let me draw this one. Okay, so so the magnetic field is in these directions. So if the velocity comes in these directions, then the length rho will produce a magnetic field. To try to fight with this B field, and for this one there will be some force which try to so basically or you can say that there will be small n, there will be small s, so it will produce s to fight with it. So there's n, and for this one, since the B field is try to leave, then it will generate B field. So it means for this B, it will have the same directions, and for this B, you will have the different directions. So if you come from here, then you can see the first one. The first one is clockwise, and the A is clockwise, and the B is counterclockwise. B is counterclockwise. So the answer is C. The answer is C. Okay, so 43. I just compute this. So this is the common sense that you can compute this very quickly. So this is IH bar LX. This is minus IH bar LY. So you get LX squared minus LY squared. So the answer is D. The answer is D. Okay. So 44 say that somebody give you a wave function in a box, and okay, what is the possible measurement? What is the following possible result of measurement energy? Okay, so if you do the measurement, then it will become phi 1 or phi 2 or phi 3. Yeah, because it will collapse into the eigenvalue. So it should be E. This is 4E. This is 9E. So the answer is D. The answer is D. Okay, so basic quantum mechanics. Okay, so 45 is also quantum mechanics. You get the harmonic oscillators, and basically what is the expectation value. Okay, so this is trivial. Okay, so let me clean the canvas. Okay, so your wave function is looks like the energy look like this. Then your Hamiltonian egon phi will become Cn En N, and so your expectation value H phi is just sigma n Cn En square, because not square, Cn square En, because n, the inner product of n is 0, So this is the answer. Okay, so what you have is 1 over square root of 14 plus 1, 1 over square root of 2 square plus 2. Actually, it's not 2, right? This 1 means what? This 1 means this 1 plus half. So this is this one, and this one is 2. So 2 plus half, so it's 5 over 2h bar omega, and 3 over square root 14 times 7h bar omega times divided by 2. So combine all of it. Oh, okay, so the answer is just direct computation. 43 divided by 14 h bar omega. So that's it. Okay, so 46. Okay, so 46 basically is the free particle, basically kinetic energy, and you have the de Broglie wave. So common sense, the Broglie wave is h over p. H over p. And then what p is? P squared is 2m times e. So it's h bar over 2m times e, right? But remember there's a potential difference, right? So your initial kinetic energy 2m should be changed to v. So you have 2m e minus v. Okay, so this is your answer, and take a square root because this is p. Okay, and you just write it down as this. Okay, so this is your original one, original h over p. So it's original lambda. This is lambda prime over divided by 1 over square root of v divided by e. Whew. So which one is the answer? Lambda times this. So answer is e. Answer is e. This is the square roots, and in the denominators. So the answer is e. Okay, I think it's enough for today. I will see you guys in the next video.